All good?
Yep. And then I'm pretty sure we look at it again, right?
Mhm.
Okay. Now they're not all not none.
And see the types? They're
Yeah,
all
look.
they're all floats.
Okay, that's good.
So now this section is more getting into like getting the training and testing sets. So let's do that. So from scikit-learn, the model selection, import train test split.
So what did you say?
From sklearn.model selection.
Alright, sklearn model selection.
Import train test split. Yep.
Right.
Okay, so now we're gonna get the what we want to predict as y, and then x is everything else. So what we want to predict is called labels, and everything else is called the features. So y is the data frame biopsy column, and so we want to get the dot values because it turns it into a numpy array.
So data frame biopsy dot values, right?
Yeah, dot values, because we want the numpy.
And then x.
Capital X.
What?
Yeah, it's just
Does it make a difference?
no, it doesn't. It's just like in most of the tutorials that you do, and like it's just a standard. But it could be literally anything. So x is df.drop biopsy. And then on the first axis.
And then make that into the first axis. Okay. First axis. One.
And you will also want the values, so dot values. And then run it.
Yeah.
There you go. And if you want, you can just do y and then click enter.
Okay.
There we go. So that's all of the data points.
Okay.
Okay. So now let's split it into testing and training. So x train, x test, and then y train, y test. Capital X though.
Yeah, why is that? Oh, it's my system. And then
It's equal to train test split, and then in train test split, you're gonna pass x, y, a random state of 1, 2, 3.
Split, and then inside it, what are we gonna do?
So pass x.
So plus x, y.
Yeah, and then a random state of 1, 2, 3.
Oh, random state.
And then a test size of 0.3, so 30% of the data for testing.
What does random state 1, 2, 3 do?
Basically, you want it to be every time you run the code, it like randomizes it, but you want the same results.
Okay.
Yeah.
And then what'd you say after the random state?
A test size of 30%, so 0.3.
And then run that. Okay. Works.
Okay, so now import Tensorflow as TF, and then oh wait.
Yeah, that's right there. Import TensorFlow as TF.
Import from TensorFlow Keras, import layers and models.
From TensorFlow, no, not TensorFlow.
Dot Keras.
Import the what?
Layers, comma models.
Layers. Okay.
And then from TensorFlow dot Keras dot callbacks.
Callbacks.
Yeah. Import early stopping. So, yeah.
Early stopping. Okay. And then
Okay.
Okay.
So these are the basic imports that we're gonna need for our model.
Mhm.
So first we're gonna want to define our input shape, as the length. So it's a tuple, so it's gonna be brackets,
Yeah.
and then the length of the data frame columns, then -1 because we don't want to include the biopsy.
And then -1 because what?
We don't want to include the biopsy column.
So,
And then just comma.
Okay.
And then we're also going to define our model architecture. So
Okay.
model is a sequential model. So one layer feeds into another.
So our model is a sequential, you said?
Yeah, sequential.
Okay.
And then it's an array in there. And it's just an array of layers.
Move it back a little bit. There's a bunch of layers, right?
Yeah. So you're gonna have a dense layer of 64 with an input shape, and then a ReLU activation, and then another one, 32 ReLU activation, 12 with the ReLU activation, and then sigmoid.
So 64 is the first one, right?
Yep.
64. And then equals to input shape. And then what's the activation?
ReLU.
Right.
So ReLU is just like, if it's less than 0, it'll be 0. And then if it's more than 0, it'll be whatever the number is.
Okay. Alright. And then what's the second layer?
32 ReLU.
32. We can just like do the activation first. Activation.
And then just do Alt Shift down twice.
12, you said?
Yeah. So 30, no, so 30, 64, 32, 12, and then 1.
And then 1.
Yeah. And then the last layer has an activation of sigmoid. So sigmoid is for binary classification of 0 or 1, and that's what we're doing here.
Sigmoid. And then you can just like tweak this line, I guess. Right?
Mm.
Wait, unexpected indent. Wait, what?
Let's see. Hover over the first line. Oh, name model is not. Oh, cause you did model.sequential. It's models.sequential.
Oh. Okay. Yes, finally.
Okay, so now we're gonna make the early sampling monitor. So when we train it multiple times so it learns from its mistakes.
Mm-hmm.
And early sampling stops it from over-learning from its mistakes. So basically knowing like exactly which so it makes a pattern, but you don't want the pattern to be too specific, so if something new comes along it doesn't recognize it. That's basically what it is.
Okay, so in this case, what does the early stopping monitor equal? Just early stopping. And then
with the patience of 2. So like after 2 epochs, if it's not getting better, it'll stop it.
Okay.
And then you're gonna compile the model.
Model.compile. compile, and then nice.
Yep. So binary cross entropy loss. It's for binary classification.
Optimizing it.
Yeah. So the optimizer is atom, and then we're gonna use an accuracy metric.
So what does atom mean? Like what in this case?
So optimizer is for gradient descent.
And then what's the metric equal?
Accuracy.
Okay. And then just close that, right?
Yeah. So you can run it.
Okay. Close it. Yeah, and it works.
Okay. We're gonna make history equals model.fit.
Model.fit.
X train, and then you're gonna pass X train, Y train, 13 epochs.
And then how many epochs?
13.
13.
And then validation split of 0.3. A batch size of 14. And then the early stopping monitor, you're gonna pass it to, so make callbacks equals early stopping monitor.
X equals early. And then you can just run it.
Yep.
Oh, where am I? So right there. With this.
Oh, there we go.
There you go. There you go.
92% accuracy, not bad.
Yeah, 93%. That's good.
Okay, so now we're gonna evaluate the model. So using model.evaluate to see how it performs on unseen data. Model.evaluate.
Wait.
X test and Y test.
Evaluate. I can't spell today. Evaluate and then X test, Y test.
Yeah. And then the Y test.
That's it?
Yep. Okay, 92% accuracy.
92% accuracy. Okay.
29 loss. We could optimize it, but we're not going to do that in this video. Okay, so now model.predict on X test just to see what it predicts.
Predict on test. Okay. So these are all the predictions, right?
Yeah, and that's it. The model is performing pretty well. We can provide a threshold. So like above 50 would be true, below 50 would be false. Yeah, it's pretty good. In a future video, we might upload this to a server, and then host it on a website.
So I think we're done, right? We're done here?
Yeah, we're done. So the model's made. The next steps would be to put it on a server and then make a website for it so people can put their data in and we'll give them the results. Yeah.
Okay, well, that was pretty fun. Thank you for your help today, Nick.
No worries. There's also another section of model optimization, but that's for future videos.
That's for future video, okay.
Yeah.
Well, thank you, Nick, and I'll see you guys in the next one.
See ya.